Now, what we're going to be talking about tonight is actually how technology has changed our way of exploration. And one of the things we always talk about is the fact that technology is always makes things so much more grand. And one of the highest technology films there was in the late 1970s, a motion picture called Star Wars. And it started off with a crawling title page. But this crawling title page, even though it's very, very high tech, was actually a uh, fairly old technology. Here it is. This is uh, that was a Flash Gordon done in 1936. And way back in 1936, they had crawling. Uh, Somebody's doing something. Anyway, but our exploration, since in the 100 years between 1871 and 1971, the technology has been absolutely startling. Uh, Way back in 1871, the wagon trains brought people out of the east, and they were able to set up uh, base camps. In 1971, we went to the moon, and they tried to set up a base camp on the moon. Now, sometimes technology is not the answer. Uh, in grocery stores right now, we have uh, actually an older technology meeting with a newer technology. The older technology is hand typing in the prices into old time cash registers, and the newer technology is our scanning. There's even newer technology than that where you actually scan it yourself. So so in spite of the superior or certainly faster technology, sometimes the best choices to make are ones that involve old technology. Which would you rather do? Stand in line where there's only one person in front of you, and the cashier basically types in the prices, or if you're standing on the back of a line and they're scanning in prices, which one would actually take less time? So at that point, uh, probably the older technology would actually be better. But we always make choices as far as technology is concerned, making choices in which line to stand on, and sometimes standing online gets to be a little strange. You always seem to make the wrong choice. Should be some music playing in here. Has that ever happened to you? You're standing online waiting to check out, and it seems like it takes forever, and you're always on the wrong line. And then finally, you think you're set up, and they're gone. In Seattle, the Amazon store will actually scan you as you come in. You can then walk out with uh, a package, and they'll actually charge you for it. Now, how many times have you bought something and then 2 days later it goes on sale. Um, something like this. You bought your Rolls Royce on Monday, and suddenly Wednesday morning you find that today only you can get it for 1/10 the cost. Now, today's exploration of our galaxy basically only covers that much. The K2 mission and the Kepler mission basically covered maybe 1/4%. And this was just in the past number of years. Meanwhile, 360 years from now, our galaxy's exploration will look like this, according to Star Trek. We will have actually populated most of our galaxy. 360 years ago, in the year 1660, this is what the US looked like. So you can see over 360 years, there is a tremendous advancement in technology. Now, one of the pet peeves that I have actually concerns warp drive. Now, warp drive, as you know, is traveling faster than light. And they always show it with these streaks of light going past you as though you're passing by stars at a constant rate. I mean, it's just ridiculous. I mean, this just doesn't seem right. Because if you were to actually take a look at the warp speed chart, you would see that if we were going at warp factor 8, if we wanted to go to the nearby star 5 light years away, it would still take us 2 days. And somehow the stars whizzing by constantly does not constitute a spacecraft whizzing by the stars. So that is definitely a false impression of traveling through space. So I don't care what you say. This is definitely not warp. Actually, this is not warp drive. This is actually a snowstorm in Iowa. Kind of looks like warp drive, though. Feels like it, too. Anyway, but looking at the warp speeds and the how warp speed were attained, we're going to take a look. We're going to take a look at a comparison of actually traveling through through our galaxy using the first generation of warp drive and then the next generation of warp drive. And as you can see, in 2063, that's only 43 years from now, we will have attained warp 1, according to Star Trek. Not even 100 years later, we will have attained warp 5, and the first Enterprise will have been built. 120 years later, I'm sorry, 220 years later, the last Enterprise was built, and as you can see, it attained warp 9.6. So the idea is that if you wait for technology to advance, sometimes that newer technology will get you there before the old technology could even get you halfway there. So the idea is, if we're going to go ahead and take a look at our warp speed chart, you can see that at warp factor 5, it takes you 468 years to get across our Federation territory. At warp 9.6, it takes you only 52 years to get across Federation territory. So if we started out with the old Enterprise, and then it would actually take 468 years to get across our galaxy. If we simply waited the 217 years for the technology to advance and then go, that would take a total of 269 years, and the new Enterprise beats out the older Enterprise by 199 years. It looks something like this.
I don't know if they'll see it.
As you can see, the old Enterprise is about halfway across. New Enterprise starts, and it just puts them flat in the dust. So if we have the new technology, we have two questions to ask. One, how long do we wait for the technology to advance? And second, where would you go once you had waited? So those are two very important questions. And some of those questions were kind of answered a while ago by a guy named the name of Frank Drake, who came up with something called the Drake equation. Now, this was not really something real. Dr. Drake actually came up with this as a way of just starting conversation. But it's an interesting concept, because at the very least, you're looking at 1,000 civilizations and probably closer to several 100 million in our universe. So the idea is, how many civilizations are out there that we think are populated? And scientists wanted to know, and they actually came up with a way of at least trying to come up with how many planets there could be. And that was the Kepler mission, the Kepler Space Telescope. And it was designed to look for planets. And the way it was going to do that was to watch stars in a certain area, and if it had planets around it, it would naturally block some of the light coming from those stars. And then depending upon how much light it was blocked by the planet, that would determine how big the planet was, and also the period of its orbit. Now, the planet had to transit the star. If the planet did not transit the star, like it went around the star, or it missed the surface of that star in the process of going around, then there was no way for us to see it. But even with that problem, even with the possibility of missing a lot of planets going around stars, it still came up with some amazing numbers. More than 2,800 exoplanets were confirmed. They actually thought they looked at more than 4,000. But the total planets within the habitable zone was 416. Now, what did they consider to be the habitable zone? That was a place around that star where the temperatures were within the possibility of water, or of having liquid water. If the planet was close enough to that star to have liquid water, but further from that star so it didn't just gas away, that was considered to be the habitable zone. And they still found more than 400 planets in that zone. And the way they did that was to take pictures of a particular area of the sky. And that particular area, they actually found a whole bunch of planets. A lot of them were Earth-sized. More of them were about twice the size of the Earth. They found giant-sized planets. They found all sorts of sized planets going around there. And the actual the actual part of our galaxy that they searched was this tiny little area about 3,000 light years wide, and certainly not very long. So if you actually measured how much space the Kepler search actually conducted, it actually came out to less than 1/4 of 1% of our galaxy. Less than 1/4 of 1%. So if 1/4 of 1% has 2,800 confirmed planets, then 100% of the sky would have more than 1.1 million planets. And that's probably a very conservative number. So scientists have set up a way of trying to come up with, okay, so if we have the technology, which planets do we go to? I mean, there's got to be some type of criteria that we need in order to, well, put our technology, put our budgetary dollars toward so that we can learn more about the universe. And they came up with a whole list of potentially habitable exoplanets, and they're ranked by distance from the Earth. Now, that's an important thing, the fact that they're ranked by distance, because you'd want to spend as little time as possible getting there. If you went by just our normal rocket propulsion, and you wanted to get to, let's say, Proxima Centauri, it would take you about 30,000 years. Now, I have things to do over 30,000 years. That way, I think that would be more important than sitting in a rocket. However, so there's got to be better ways of getting there. So they picked out the closest planets to us. And the closest one that actually has, the possibility of being habitable is Proxima Centauri, part of the Alpha Centauri system. It's only 4.2 light years away. That's like right next door. So there's a good possibility. Let's put that in the back of our head, and we'll come back to that. So they took a look at a map of our local group here, and they found that there's a lot of planets out there that could be habitable. And as a result of that, they're starting to possibly plan missions to those things as soon as they figure out how to do warp drive. Of course, that's pretty much in the future. According to Star Trek, that's 43 years in the future. I can hardly wait. Anyway, but so they started taking a look at planets that are close to us, and they ranked them according to similarity. They came up with a similarity index. So how many of these close habitable exoplanets are like the Earth? As you can see, the Earth is given a 1.0. Take a look at Proxima Centauri. That's at 0.85. So that's pretty close. So maybe we should be putting our bucks away and saving up to go to Proxima Centauri. Actually, that's already happening. There is a plan out there called Breakthrough Starshot. And the idea is to send a probe to the Alpha Centauri system. The Alpha Centauri system is 4.37 light years away. And if you went there with conventional rocket engines, again, it would take you about 30,000 years. But let's not use conventional systems. Let's go ahead and actually make a robot. And not one robot, but let's make hundreds of thousands of robots. So Breakthrough Starshot is actually sending a probe, going to create thousands of nano spaceships, and then blast them out there using solar cells and a tremendous amount of laser energy to actually push those nanoships to about 20% of the speed of light. Traveling at 20% of the speed of light, it would still take 20 years to get to Alpha Centauri system. And then once it got there, it would take 4 years to receive any data that those robot nano spaceships would send back. So looking at the timeline, it would take 20 to 30 years to solve all the technology challenges that would go into building these components and then launching them. And then you figure 20 years of travel time, and then finally 4 years to receive the data. So we can have a probe to Alpha Centauri within 50 years. But I said that according to our supposed history, Zefram Cochrane comes up with warp drive in just 43 years. So in 2063, Zefram Cochrane comes up with warp drive, and let's say he immediately starts out for Alpha Centauri. Meanwhile, the nano spaceships are on the way. And about when they get out to about halfway, Zefram Cochrane is getting his spaceship ready to go out there too. And he gets out there and gets a reply 4 years faster than we can do on using Starshot. Now, technology gets even stranger than that. If we start looking at the age of our universe, then the weight gets really strange. Because if planets were born, let's say 5 billion years after the Big Bang, but 4 billion years before our solar system is created, then these planets, the planet X, actually have a 4 billion year head start from us. So at that point, we see how much technology has changed in 100 years. Imagine where it would be if that advanced planet had 4.5 billion years beyond where we are today. I mean, to me, there's no doubt at all that they would be so advanced that traveling between stars would pose no problem for them whatsoever. So our universe should be just teeming with life. The other thing which is interesting here is the fact that according to some geologists, uh, if the planet was formed, just 5 billion years after the Big Bang, the chances are they would have a better chance of having plate tectonics and therefore having magnetic fields, and they would have a better chance of developing life than the planets would have today, because they would have the possibility of higher metal content in those planets. So based upon the fact that these older planets would be more advanced, there would be a tremendous amount of life out there. And you'd think we should have heard from them. Someone should have knocked on our door by now. Well, in the 1950s, a scientist by the name of Enrico Fermi asked the question, where is everybody? This is called the Fermi paradox. The universe is big, the universe is old, it has all sorts of stars. Where are they? Where are these advanced civilizations that supposedly our universe should be full of? So Enrico Fermi said that there should be 10 gazillion intelligent civilizations out there. In less than 100 years, humans went from traveling in covered wagons to landing on the moon. The technology is advancing. So where is everyone? And there are a lot of answers to this. Some of them are rather interesting. For instance, perhaps we're just not looking at the right frequencies. Our wires are crossed. Maybe they're out there, but they're kind of watching us. So they don't want to be discovered. Or maybe, according to Charles Darwin, it's the fact that the strongest will survive. So maybe we have to watch out for other aliens that might take us by surprise. Maybe space is just plain too big. I mean, it does. I mean, our visible universe is 40 some odd billion light years wide. That's a lot of space out there. Maybe they're already here. According to ancient astronauts, they're here and they're learning all about us, or that we don't know where to look. Or maybe they're invisible. They'd use high tech to spy on us. And then, of course, the other thing is maybe we're the aliens. Maybe we have a history of being created somewhere else. I mean, according to our circadian rhythms, according to how our brain works, we are actually more suited in terms of time to live on Mars than we are to live on the Earth. Now, some scientists have actually come up with a method of trying to come up with how much their technology has changed. Perhaps there's a way of categorizing where we are as far as technology is concerned, and that's called the Kardashev scale. So Nikolai Kardashev was trying to take a look at technology and seeing where we are and where advanced civilizations could be as far as using technology is concerned. So the type 1 civilization would harness all the resources of a planet. According to Carl Sagan, we're not there yet. We're somewhere between zero point 0.5 and zero point 0.7. The type 2 civilization harnesses all the radiation of a star. And it's generally believed that humans might reach type 2 in a couple or 3,000 years. Type 3 civilizations would harness the resources of a galaxy. Now we're looking at millions of years of evolution. Type 4, 5, and 6 are really, really quite advanced. If we go ahead and we have a whole list of them, you can see that we are, at this point, we are pre-planetary. It extracts its energy information solely from planetary resources. That's where we are. So right now we're about a 0.7. If we take a look at the world of Star Trek and the resources they use in order to get where they're going, it's been estimated that Star Trek, the time of Star Trek, is actually about a 1.1. Meanwhile, if you take a look at Star Wars, now Star Wars, the Empire used the resources of an entire star. Remember when they built that killer moon? So actually, Star Wars is at 2. So they're at K2 as far as their scale is concerned. Have we ever seen anything more than that? Actually, in Star Trek, we have. And that's the continuum jumper Q. Q is actually rated about a 4 on this scale. Now, he's not omniversal. He is universal. In other words, he uses our universe to travel around in. But he doesn't do more than that. And he is, I guess you'd call him, he is vulnerable at that point. So looking at all this, looking at this science fiction, is there any evidence to the existence of any of these civilizations? And actually, there is. Right over here in Cygnus, there's a star in there. Right next to Delta Cygni, off at the end of that red arrow, KIC 8462852. That sounds like a wonderful name for a star. It can't be seen with the naked eye. It was listed by the Kepler star finder. It's a planet the size of Jupiter would only obscure about 1% of the brightness of that star, yet there is something that's obscuring more than 22% of that star. And scientists have looked for radio emissions from the possibility of extraterrestrial life going around that star. They don't know what's going on in that star. Star does not act normal. First of all, it covers a huge bandwidth. I mean, it's huge compared to stars. So there is something going around it. And they've made all sorts of possibilities. For one thing, there might be a solar system that's forming around that star. Or maybe it's a whole bunch of the planets that are slowly eating themselves up around that star. Or maybe there's a whole bunch of comets that are slowly coming apart, obscuring the surface of that star. But if you look at the light curve of that star, it doesn't look like it's anything stable. It looks like it's covering more and more of that star. And there is, according to some suggestions, including a paper that was submitted by Harvard University, that star is actually a remnant, or perhaps a home base for intelligent life, where they are building a Dyson sphere around that star in order to capture its energy. So that would be a type 2 civilization going around that star. There are other possibilities too. For one thing, life might be extremely rare. This might be the antithesis of the Drake equation. There are remarkable coincidences that have to happen for life to flourish. And here on the earth, the number is absolutely amazing. For one thing, we started off with a ammonia methane atmosphere with carbon dioxide, some water, some sulfides, and lots of lightning. And you can see a moon out there, and the moon is only 10,000 miles away. You see, the moon was formed shortly after the Earth was. And right now it is slowly moving away from the Earth at something along the lines of about 1.5 centimeters per year. So in several billion years, the moon will be far enough away where it'll no longer cover the sun for eclipses. It'll actually be in locked tidal motion with the Earth, which means that the Earth and the moon will always be facing each other. And a day on the Earth would be about 40 hours long. So the moon seems to have a great deal of importance to the Earth, and we'll talk more about that. But during this time, the Earth is getting bombarded by hundreds of thousands of meteors. Now, during this time, the Earth is also covered with water. And this water slowly coalesced and filled the oceans. And then because of the moons, those oceans had tides. And these tides would actually fill and empty tidal basins. These tidal basins filling and then draining were actually the testing grounds for life forms. It was actually within these tidal basins that water would actually dissolve a lot of the materials and dirt and sand, and actually form some of the organic chemistry that would eventually become life. An experiment in the 1950s by scientists Miller and Urey actually took the primordial atmosphere of the Earth and subjected it to lightning, to gases, to heating, and they found that from these raw materials, amino acids were formed. Now, amino acids are not life, but they are important chemicals for the formation and and how life is substantiated. Plus, we've had lots of meteors coming down and striking the Earth, and many of these meteors would have organic materials that would be brought to the surface of the Earth and mixed with whatever chemicals happen to be mixed here on the Earth. According to the Dawn spacecraft, the dwarf planet Ceres actually had organic chemistry on the surface of that planet. And apparently this is nothing new. I kind of put that in there. It's kind of fun to see the bugs running around. But Ceres, if Ceres has organic chemistry, then it must exist everywhere in our universe. And where you have organic chemistry, you have the possibility of the structure of life. Here you have RNA forming membranes that would protect it. And from these protected membranes and RNA, eventually DNA could form. And a lot of this stuff would actually form around the underwater volcanic vents, where you have hydrogen and other organic materials being erupted from the interior of the Earth, mixing with water, and then the energy of those volcanic vents would actually form life. An interesting part of all this is the fact that if you look at the DNA here on the Earth, you find that virtually all DNA is right-handed. In other words, the right side of DNA goes over the left side. So why is that? I mean, DNA could form either way, but virtually all life on the Earth has right-handed DNA. According to research done at the University of Nebraska at Lincoln, left-handed DNA was destroyed by cosmic rays, which are also mostly left-handed. So the question comes up, what would left-handed DNA look like? What would left-handed DNA life forms look like? Another coincidence that is really kind of strange is the fact that we have a magnetic field going around us. And this magnetic field protects us from high energy particles from the sun. And these high energy particles are diverted from the surface of the Earth by this field. Without this field, the life forms on the Earth simply would not exist. It would be more like Mars, and Mars is fairly sterile. So high energy radiation will damage the generic material, and then we have substitution mutations, where perhaps the mutation would be something better, or most likely something worse, where the mutation wouldn't be able to survive. It's these mutations that have been able, that have survived, that have actually evolved into the life forms we have today. It's taken several billions of years, but they've done it with the help of bacteria. Now, bacteria, again, is just basically a little pocket of generic material. And this generic material might be mutated by the energy coming from the sun, just happens to get hit by a little piece of radiation, and then it might try to form some type of life. It may or may not take. Most of the time, it'll just die away, and then the tides will simply take away that material until finally the bacteria will form some type of life form that will survive the tremendous amount of radiation coming from the sun. And it'll thrive. And as it thrives, it will change. It'll actually mutate into other life forms and progress in its life forms to the point where, until we are. But there is another piece to this puzzle, and that is the sun. There we go. Our sun, we think of it as a normal star. It's a white dwarf star, has a surface temperature of about 5,000 or 6,000 degrees. It's been around for about 5.5 billion years, and it has about another 5 billion years to go. But our sun is a little bit on the strange side, because if you take a look at our sun, it's actually giving off energy in this part of the spectrum. Natural sunlight is right in the middle of what we would call our visual spectrum. Now, our visual spectrum is right in the middle of that. Now, the question comes, do we see this because of the sun? Or does the sun does this and then we evolved from it? But one thing which is interesting about this is the fact that photosynthesis occurs at these frequencies. And photosynthesis is the driving force that actually caused the earth to become filled with life. Now, way on the edge of this spectral distribution is this part of the spectrum, and that part of the spectrum is the ultraviolet, and that's the part of the spectrum that is dangerous to us. And at this point, it is being blocked by the ozone layer. Now, it's because of photosynthesis that we have the life forms we have today, because it was photosynthesis, it was the sunlight, the actual frequency of the sun that caused the bacteria, the chloroplasts, that was a form of bacteria, to use the sun's energy to create food for plants. So under the sunlight, we had the formation of chloroplasts, which were mutated to become part of slime mold and brown algae, which created a great deal of oxygen, which the oxygen actually took over. And it took over to the point where mitochondria, another bacteria, actually mutated in order to use that oxygen. So our cells, because of endosymbiosis, actually have mitochondria, and our plants have chloroplasts in them. That those mutated bacterium was actually a response to the sun's frequency and the advancement of oxygen. So we have two bacterias benefiting from the arrangement. So if we look at modern cells right now, you can see that they have mitochondria, at least the animal cells do, and we have plant cells that have chloroplasts in them. And again, it was a response. It was a mutated response to what was happening here on the earth. Now, all of these things could be the result of something else. And we call those things great filters. Now, the great filter, if you take a look at option number one, perhaps our great filter was the formation of chloroplasts that would eventually produce oxygen, and then the mutation of mitochondria. Or maybe we have option two, which maybe the great filter would not only let some life forms exist, but maybe there's another life form that's incredibly lucky and has gone through the great filter. That could also be ours, because there's a great deal of life under the oceans that do not use oxygen, that do not use typical plant foods, but are actually using the energy from the sun and using the methane that's produced by these vents. Perhaps there is no great filter and everything's going to evolve. Or yet there might be another option, and that is the fact that perhaps the great filter is still in front of us, and we still have to get past that. And that is really scary, because great filters could be a number of things: an asteroid strike, alien invasion, space radiation, or perhaps we'll destroy ourselves through war, pollution, or disease. That last one right now is really scary. Anyway, there is one more possibility, one more, and that is the fact that we haven't found any evidence of extraterrestrials, because our reality is an elaborate illusion. We are living within a computer simulation created by alien overlords who make all the rules. Kind of like the Matrix. Even Albert Einstein said, reality is merely an illusion, albeit a very persistent one. If that's the truth, then we'll never find any extraterrestrials. They don't exist. We have no one to talk to, where there is no place to go, and nothing is real. That's kind of a sad way of looking at things, but our next series will actually be landing on planets and seeing what the possibilities are on each of these planets. So potatoes on Mars, tube worms on Titan. By the way, all of these programs, this was the last of the series. The programs can be seen on YouTube if you search for Drake Observatory, Herb Schwartz. You will find all of the programs. So at this point, I will go ahead and ask if there's anyone that has any questions. Looks like there's a whole bunch of chats on here.